In this video, we're going to discuss our last example in this demo program, video 14.1, and it is going to sort of like generalize the idea of frame-by-frame animation. We are going to use our next demo program, animate for next frame, and the huge change that takes place, absolutely new, revolutionary idea, is that we would like to control the animation speed. Remember, in the previous example, we always, including this last example in the previous video, we always, in every iteration of our loop, we generated output to slow down the progress of our program, because it takes time to display the characters that we try to display. Now, this time, we don't want to rely on the speed of our computer environment. Instead, what we want to do, we would like to introduce a frame per second parameter, right? So we'd like to specify how many FPS, or frames per second, we would like to see, just like in a cartoon or a movie. So first, let's define some system-wide global parameters. And this time, we need to start using global parameters, because the idea behind this new program organization is that animate for next frame. This is my latest function, which was added to this demo. It will be invoked for every frame. And so, to be able to retain the status, the state of the entire animation, we need to rely on some kind of global state variables, which we can update on each invocation of this function. So, what kind of variables do we need to control the entire animation? Frame index, which will go from 0 to maximum. Frames per second speed. I choose 24, which is a classic animation speed. Frames per second. So we should be able to get somewhere in the vicinity of 24 updates on the screen per second. And the frame interval is simply the time interval needed to delay the time between every frame. It's actually computed. You can see that this is a division operator in Python, which of course generate a float data type. And this basically is the time delay between the two consecutive frames, between all of the frames. And the units of measurement are seconds. So this is like 1 second divided by 24. And so this is the time interval needed to be weighted before displaying the next frame. That's the speed that we choose. All right. So to be able to implement the delay itself, we use the threading library, which we import, and we will be using the timer. So the timer simply schedules next frame display using this specific interval. I'll show you the example. And just a little note that, of course, the computer speed, the environment of our computer speed, is going to be a contributing factor. So in reality, we try to measure exact time intervals between every frame. There will be some kind of time drift introduced into this, but it's absolutely negligible for our demo. So we'll just use this, specific frame per second. But in reality, there is a deviation. There is a little bias, and there is a drift into a longer time, very likely, which will be the actual time delay, but negligible for what we're trying to demonstrate. All right, so this is the function itself. And notice that I don't use any parameters anymore, because I completely rely on the set of global variables: frame index, which goes from 0 to maximum frames per second frame interval. And here the maximum now is a global parameter. In fact, this is where it's set. Just before we make a call, we make it a global variable. We set it. This time I set it equal 100, and I begin the animation. Most of the global variables do not change here, okay? However, frame index will be incremented. Every time we call this function, the frame index will be incremented. So we go from 0 to the maximum. That's the range in which the frame index will be changing. So in such case, Python requires that you declare this variable to be a global variable, and then you can change it. These variables, frame interval, backdrop, and the maximum parameter, they do not change. This function does not update their values, so they don't have to be declared global, but we could do that. But we require to do this only when the variable will actually change. And so with every call to this function, and look, this is exactly what we do. We make a call into this function, and what it does, it is responsible for displaying one single frame of our animation. So let's see what it does. So we say this here, right here, a frame begins. Again, we split the backdrop into a list of little characters. We say that frame index is the part of the animation that we'd like to display. Again, we choose some arbitrary position, and we say that for every character we want to display, we extract the character from the character to display, and we update the frame at this position where we would like to make every display, and we add 3 to keep the digits that we'll be displaying, like 3 characters apart, and then we reassemble our frame and print it. Okay, so we'll be printing every frame. And this is the work complete for the first frame. Okay, so the first frame is complete and printed. It's all done inside this animate 4. But something interesting is happening next. So the next thing that we do, we say that as long as frame index has not reached the maximum, we're going to increment it by simply adding 1 to it, and we will use the timer function to create a new thread of execution. And it's just the way it works in Python. It will be a parallel execution in our program. We start the timer and we say this is the frame interval, which we computed so that it corresponds to 24 frames per second. And after this interval of time, I would like to use this function. This is the name of our function in Python, right? And we say that we want to use the timer delay, call this function on a separate thread, and this is why we need the threading library. And the actual launch signal to this to start proceeding is start. So in other words, this animate next frame example animate 4 will restart itself after specific interval of time. And this is why just what we do is we define the maximum and we make a first call, and then the rest of the calls for 0 1 2 3 4 5 all the way through 100 will be executed by these consecutive invocations of the same function on a separate thread of execution. Okay, so let's run this demo. I'm just going to simply continue what we have started already. We haven't made any changes. Just start, and you can see that this is arbitrarily at 24 frames per second. We ran this animation here. Okay, so this worked very well, and so the whole the whole intention and what I call the next big idea here is that we can now specify a frame per second speed, right? How often would like to run this animation on a frame by frame basis.